Smart Grid 2.0 is not just a better version of today's grid. It is the backbone of a future Internet of Energy where every home, electric vehicle, and device can buy, sell, and intelligently manage electricity in real time. In this video, you will learn how this next-generation grid works, the technologies behind it, and why it is central to achieving a net-zero energy system by 2050. Imagine living in a neighborhood where your rooftop solar panels automatically sell extra power to your neighbor's EV, your home battery gets paid to support the grid during heat waves, and blackouts are rare because the grid repairs itself in seconds. That is the promise of Smart Grid 2.0, a fully digital, intelligent, and decentralized electricity system that turns every consumer into an active prosumer. In this video, we break down what Smart Grid 2.0 is, the core technologies making it possible, and how it will transform daily life between now and 2050. The grid most people rely on today was designed for one-way power flows. Big power plants generate electricity, and it flows down to passive homes and businesses. The first wave of smart grids, often called Smart Grid 1.0, mainly added digital meters so utilities could read consumption automatically and bill more accurately, but customers still remained largely passive. Smart Grid 2.0 is a step change. Data, control, and intelligence move from a central control room out to the edge of the grid, into meters, EV chargers, solar inverters, and local controllers that can act in near real time. Under the hood, Smart Grid 2.0 replaces heavy, passive, oil-filled transformers with compact, semiconductor-based solid-state transformers that can precisely control voltage, handle AC and DC, and support bidirectional power flows. These devices can be up to 65% smaller in volume and reach efficiencies above 97%, which is critical for dense applications like ultra-fast EV charging hubs and AI data centers. At the same time, the grid is shifting from grid-following inverters, which rely on the existing grid to operate, to grid-forming inverters that can actually create and stabilize voltage and frequency, enabling microgrids and black start capabilities without large spinning generators. The data explosion from billions of connected devices makes it impossible to send everything to the cloud, so Smart Grid 2.0 pushes analytics to the edge using embedded AI in meters, chargers, and local controllers. Neuromorphic chips and specialized neural processing units allow these edge devices to run powerful AI models at ultra-low power, detecting equipment failures or cyber attacks from subtle waveform anomalies before they cause outages. With federated learning, devices collaboratively train shared models by sending only model updates instead of raw customer data, improving forecasting and control while keeping user data private and local. As more homes generate and store their own energy, traditional top-down markets struggle to manage millions of tiny, bidirectional flows, which is where transactive energy and blockchain step in. Blockchain-based platforms make it possible for neighbors to trade energy directly with each other using smart contracts, with transparent, tamper-resistant records and high transaction speeds at millisecond-level confirmation times. Smart contracts can automatically match bids from home batteries or EVs, settle payments instantly once delivery is verified by IoT-enabled meters, and even use reputation scores to prioritize reliable participants. Virtual power plants aggregate thousands or millions of small assets, rooftop solar, home batteries, smart appliances, and EVs, so they can behave like a large, dispatchable power plant. By 2030, scaling VPP capacity to around 80 to 160 gigawatts could cover 10 to 20% of peak demand in markets like the United States and save billions of dollars annually compared with building new gas peaker plants. The market is rapidly moving toward mixed asset platforms that control solar, storage, and flexible loads together, bidding multiple services like peak shaving, frequency regulation, and capacity into different markets simultaneously. As extreme weather becomes more frequent, Smart Grid 2.0 aims to make the network both tougher and smarter, using self-healing distribution systems that detect and isolate faults automatically. Technologies like pulse-closing test lines with low-energy pulses before reclosing, greatly reducing mechanical stress and avoiding unnecessary outages. while flexible interconnection devices reroute power between feeders in milliseconds. Utilities deploying these self-healing capabilities have already cut tens of millions of customer outage minutes, demonstrating that smarter control can be as important as building new lines. China, the United States, and the European Union currently lead the global rollout of smart grid technologies, but each region focuses on different strengths. China has aggressively modernized its high-voltage systems and is now extending automation into medium and low-voltage networks to support rapid renewable growth and carbon neutrality targets. The US is pushing ahead in virtual power plants and grid-edge analytics, while the EU emphasizes prosumer participation and cross-border integration to hit ambitious clean energy milestones like the REPowerEU targets for 2030. By 2050, renewables are expected to supply the vast majority of global electricity, and prosumers could generate a significant share of their own demand in many countries, fundamentally changing the utility-customer relationship. The vision is an Internet of Energy where energy is routed like data packets over a network of smart switches, routers, and gateways, with AI using predictive, anticipatory control to keep supply and demand balanced in real time. Milestones on this path include massive VPP deployment by 2030, widespread grid-forming inverters and microgrids by the mid-2030s, neuromorphic edge AI, enabling autonomous fault recovery by the 2040s, and fully self-organizing energy markets toward 2050. Smart Grid 2.0 is the technological engine of the global energy transition, combining power electronics, AI, blockchain, and new market designs to deliver cleaner, more reliable, and more participatory energy systems. If you want more deep dives into future energy technologies, from virtual power plants to vehicle-to-grid and the Internet of Energy, hit like, subscribe, and share this video with someone who still thinks the grid is just wires and poles. Drop your questions in the comments about any of the technologies covered today, and suggest what part of Smart Grid 2.0 you want to see unpacked in a dedicated follow-up video.